Most software follows instruction. Agent perceive goals. If that sentence sounds simple, hang with me. Because it's actually the biggest shift in how we build software since object-oriented programming. Think about the app you have ever written or used. You give it an input, it follows the path you defined and get an output, predictable, deterministic. Honestly, kind of boring. Now think about an agent. You give it a goal, plan my trip to Tokyo, and it figures out the path itself. It sends, it plans, it acts. It learns from what just happened and then it does it again. That's not a fancier program. That's a different category of software. In this episode, we will unpack the architecture, the life cycle, and the real world money that is already making. Quick honesty check before we dive in. When you hear about the word agent, is your first thought chatbot? By end of this answer is going to feel embarrassingly small. Let's start with what actually going to walk away with. Here's a promise. 6 concrete things you will be able to do or explain by the end. By the end of these 15 slides, you will be able to define what makes an agent. 6 straight, not vibes. You will map the cognitive loop every agent runs on. You will know when to reach out reactive brain versus the deliberative one, versus a hybrid. You will understand the 2 protocols that lets agent talk to tools and to each other. You will know the 7 phases of life cycle of a shipping of these things in production. And you will have a maturity map of your own org. 6 scale, 15 slide. Pretty good ROI on your attention. Now pause and predict. Which of these 6 are your weakest on? Mentally bookmark it, and that's the part to slow down on. Okay, foundation first. What is an agent really? Forget the textbook definition for a second. Here is a 6th trait that actually separates an agent from a regular software. Autonomy. It acts without the babysitting. Persistent. It remembers across session, not just chat. Reactivity. It notices when the world changes. Proactiveness. And this is where things get spicy. It can start things on its own, on interval goals. Adaptability. It's get better from experience. Goal orientation. It doesn't just react. It plans towards something. If you build a thing that it tick all 6 of these, congratulations. You build an agent. If it ticks 2 or 3, you build really nice middleware, but both are valuable. Just call them what they are. Okay, now tiny challenge. Pick your favorite SaaS tool. Mentally score it on these 6 traits. I bet most of these AI-powered ones score above 2. So how we get from the spreadsheet to system that have all 6? Quick history lesson, and it's shorter than you think. 50 years of AI history in one slide. 4 eras, each one fell in a piece, last one was missing. 1970s to 80, rule-based expert system, stuff like mycin, which could diagnose blood infection better than most doctors. Brilliant but completely brittle. Change anything and it breaks. Then 90s came. Classical machine learning, decision tree, SVM. Suddenly machine could pick up the pattern from data, but they still have no memory of what just happened. 2010, deep learning, vision, speech, translation, superhuman in narrow task, but still basically input and output, no agenda, no goals. Then 2020, LLMs walk in with the emergent reasoning, plus tools, plus memory system, plus orchestration frameworks, and for first time you can stitch together something that is goal oriented and stateful. That's the moment AI agent stops being a research term and become things you ship. Look at the customer support example. Static FAQ script in 2010, ML route in 2018, multi-agent resolution at 70 to 85% today. Same problem, 3 completely different architecture. That's the speed of this curve. Okay, what's actually inside one of these things? Let's pop up the hood. Every agent, every single one runs on this 5-step loop. Memorize it. Perceive, it pulls signals from the user, API, sensor, whatever. Reason, it figures out what those noise actually means, what important, what's noise. Plan, it breaks the goal into steps that order them sensibly. Act, it actually calls the tools, fires API, does the things, and learn. It scores how that just went and updates its memory or its policies. And here's the part most explainer skips. This isn't pipeline, it's a loop. It's a loop that learns the learn phase feedback into the perceive. No, so every cycle the agent gets a little smarter about the same kind of problem. That feedback loop is different between the workflow and the actual learning system. Okay. Quick check. Your fancy chatbot, does it learn? Does the output of the last week conversation actually change how it handles tomorrow's? If not, it is stuck in step 4. Now its loop runs inside a brain that has more parts than just a LLM. Let's look at the wiring. An LLM alone isn't an agent. It's an engine. A car that still needs steering, brake, dashboard. Here is the wiring diagram. AI at the center is the cognitive core. The executive, the synthesizer, that synthesizes everything around it, 5 conversation partners. Profile and personas. Who is this agent? What is the tone? What is the guardrails? Tool uses, how it reaches out to API and external systems. Planning and feedback, how it decomposes goals and recover when step fails. Knowledge and memory, short-term, long-term, episodic, agent sense of history, and reasoning and evaluation. A distributed set of validators checking for safety, functionality, confidentiality. Notice the word distributed. Production agent doesn't rely on one monolithic reasoner. They use specialized checker runners in running in parallel, belt suspender and belt backup belts. Pause and ask yourself, if your current agent setup, which of these 5 is weakest? Memory is always the answer, almost always. Now, depending on how you wire these parts, you get 3 completely different kind of agents. 3 brain, each one right for different job. First brain, the simplest. Think of it as your thermostat. Reactive agents are pure reflex. If the temperature drops below the threshold, turns on the heat. No memory, no planning, no opinion. Just if X then Y. And before you roll your eyes, this architecture is the right call more often than you think. Anti-lock brakes in your car are reactive. They have to be. You can't afford a millisecond of deliberation when you are skidding. Fire alarms are reactive. Game NPCs that needs to look alive are reactive. The downside, they can't generalize. The firearm that sees steam from your shower will scream just as loud as when it from your real fire. No context, no adaptation. So when you hear something trash talking simple system, remember something simple is exactly what a job needs. Here's the question. Anti-lock brakes are reactive on purpose. Why would adding deliberation make them worse? But sometimes the job actually does need strategies. Brain number 2. Brain number 2, the strategist, this one stop thinking, plans, then acts. Deliberative agent runs the sense model plan act loop. Imagine I tell my agent, travel assistant, I want to fly to Tokyo next month. A reactive agent has no idea what to do with that. A deliberative one sends the input model it by pulling out the structure, designation Tokyo, time frame next month, preferences to be determined. Then it plans flight, visa, requirement, hotel in a right order because you need to have a visa before you book the flight. Then it acts by calling Skyscanner, retrieve visa rules, presenting hotel option. The superpower is that it handles novel situation and coordinates across multiple tools. The trade-off, it is slower and its internal word model is stale or wrong. It confidently does the wrong thing, so in production, you always pair it with fallbacks. rule, escalation path, or human handoff. Pause and predict. How AI fight Booker hits a visa snap. What should a deliberative layer do first? Replan, ask the user, or escalate. Here is a single, there is no single right answer. And that's the point. Now, what if you need both the reflexes and the same strategy? That's the brain number three. Brain number three is hybrid. Think of it like a fighter pilot. Fast reflexes plus strategic mission plan running in parallel. Hybrid agents stack a reactive layer and a deliberative layer, and they talk to each other constantly. Imagine a warehouse robot delivering packages. It runs a deliberative plan, the optimal route from A to B, then suddenly fallen box. The reactive layer slams the brake before the deliberative one, given the finish a thought. But this is the cool part, and that's the hit box. Signal flow up to the deliberative layer, which replans the route. And meanwhile, the deliberative layer might tell the reactive one, hey, battery is low, slow your max speed. Bidirectional. Constant in real system, your wire this with the message queues, Kafka, RabbitMQ, AWS SQS. So two layers can run truly in parallel without stepping to each other. Reactive under 100 millisecond, deliberative on a scale of seconds to minute. Best of both the worlds. Here's the catch. Hybrid systems are powerful. Most production works live in the coordination between the two layers, not in either layer alone. Remember that when you are debugging. Now, once you pick the brain, you need to talk to the outside world. That's where protocol comes in. Two protocols, two different jobs. If one only remembers two acronyms from this episode, remember these. MCP, Model Context Protocol, is how agent talk to tools. Every tool registers itself with machine readable description. What it does, what input it takes, what output it returns. The agent can then discover what's available at runtime and invoke any of it through one standardized interface. Translation. You can swap or upgrade tools without rewriting your agent. Then there is A2A. Agent to agent protocol, that's how agents talk to each other. They exchange three things: state, role, and status. State is the shared contract. Role is who does what. State is successful, ready. Together, this lets you build teams of agents that coordinate without the center boss. So trans agent passes to billing specialist who passes the compliance validator, and of them they fail without bringing down the whole pipeline. Here is the simple MCP version, agent down to tools. A2 is horizontal, agent across other agent, different problem, different protocols. So MCP is vertical agent down to tools, A2 is horizontal agent across to other agents. Okay, you understand the architecture. Now, how do you actually ship one of these things? Welcome to Lifecycle. Building an agent isn't building a regular app. It's a different life cycle. 7 phases, and the last one never ends. Phase 1, conceptualize, not just gather requirement. Model the cognitive workload. What is the agent supposed to think about? Phase 2, architecture. Design, pick your cognitive model, react, BDI, plan and execute. Pick a model, memory model. Phase 3, implement, wire it together with LangChain, CrewAI, LangGraph, and critically backed cognitive workflows. Test into your CI. Phase 4, evaluate, not just did it pass test, but task completion rate, latency, escalation frequency, user trust. Phase 5, govern, versioning, rollback, compliance audit. Phase 6, monitor landscape, Prometheus, what state errors, hallucination rate. Phase 7, iterate. Forever, the minute you ship you are ready for collecting data to retain on, the life cycle never closes. Quick check. If you are already building agent, which of these phases are you actually doing. My bet implementing the evaluate. Most teams skip governance and serious monitoring until something embarrassing happened in production. Now, not every agent needs to be fully autonomous powerhouse. There is a spectrum, 5 levels of agent interactions. Here is a spectrum 5 levels. And the right answer for your problem is almost never the most autonomous one. Level 1, direct LLM interaction, stateless. You prompt it answer, great for one of Q&A for or creating writing tools. Level 2, proxy agent, takes messy natural language, turns it into clean structured input for backend system. Think voice command to API. Level 3, assistant system. Now we have session memory and tool uses. Notion AI, enterprise digital assistant. Level 4, autonomous agent, persistent memory, multi-step plan, real independence, research bots, DevOps, automation. And level 5, multi-agent system, a team of specialized collaborating, self-driving stacks, trading platforms, smart home orchestration. Here is the warning that comes free with the slide. More autonomy isn't always better. Each level add power and failure modes. Match the level to the risk you can absorb. Tiny challenge. Name a use case where level 2 beats level 4. Hint. Anywhere the cost of mistake is bigger than the cost of extra round trip. Okay, levels are one way to slice this. There is another framework, and this is the question your CTO is going to ask you. The pyramid of maturity. Where does your organization actually sits? Level 0. Manual operation, no automation. Humans do everything. Don't laugh. This is enterprise-backed office. Many are working in the same level. Level 1, reactive rules-based automation. Templated emails, replies, RPA tool, filing bombs. Level 2, tooling use agents. LLM that can call functions, chain operations, pulls from knowledge base. This is where most AI initiatives lives in 2026. Level 3, planning agent, goal decomposition, context awareness, multi-steps. Travel planner, employee onboarding orchestrator. Level 4, learning agent, they adapt, personalize, evolve over time. Fraud detection that grows with new attack pattern. Recommendation engine that generally models you. Here's the spicy truth. More companies that think they are at level 4 are actually in the middle of level 2. Be honest with yourself, then plan the next steps. Pause and rate your team. Be honest. The honest answer is the one that actually unlocks the next move. Theory is nice, but any of these actually makes money yet? Short answer, yes. A lot. Let me show you. This isn't someday's technology. It's the already revenue. 3 quick case studies. Quantity, insurance process. Agent process thousands of policies daily for 99 percentile with 99.9 percentile accuracy in 15 minutes. Per policy where human took hours. $30,000 monthly recurring revenue from one product. My Ask AI financial service support. Customer queries resolved in under 30 seconds. CSAT above 99 percentile. 25,000 MRR. And the agents know exactly where to escalate to the human, which is half the trick. Enterprise bot, multi-agent sales team, a specialized agent for lead enrichment. Qualification, outreach, and meeting coordination. Triple the qualification leads, half the acquisition cost, $2 million annual revenue. The pattern leans teams into sophisticated agent orchestration, are running circle around competitors, 3 times the size. The gap is widening fast. Watch what happened here. None of these are flashy consumer app. They are boring enterprise problems. Insurance form, customer support ticket, sales outreach. That's where money actually is. All right, big picture. Let's log the 5 things you walk away with. Five things, burn them in, and this is your takeaway. One, agent pursue goals. Software follows instruction. That's the whole difference, and everything else flows from it. Two, every agent runs the perceived reason plan, act, learn, loop. Five steps in a circle forever. Three, pick the right brain, reactive or reflex. Deliberative for strategy, hybrid for when you need both. Four, MCP connects agent to tool. A2A connects agent to each other. Two acronyms, two different jobs. And five, match interaction level and the maturity stage to the actual problem, not the whoever loudest on Twitter. If you walk away with these five, you are already thinking about agent more than 90% of in the market. If this clicks, drop a comment with which of these brains you are building right now, reactive, deliberative, or hybrid. I read them. Next episode, we get our hands dirty with the actual tools and frameworks, LangChain, AutoGen, Creo AI, language model selection strategies, the whole working toolkits. That's the chapter 2. See you there.